All right, so now we're going to start with TypeScript and classes. So on this video, this section, I'm going to show you first. I'm going to refresh what we know about JavaScript classes. So I'm going to just write a little bit of code because maybe you don't remember classes that much. Maybe you don't use them a lot, but I kind of need to refresh your memory about this just a little bit. If not, you're gonna get a little bit lost. So I'm going to do something very simple. I'm going to create a class of an instrument. Let me just do that. I'm going to say class instrument, all right? And on the inside the class, we will get a property, in this case, which is the amount of strings of an instrument. And then I'm going to do, I don't know, a property called sound. And whenever we use this one, we are going to do just the console log of classic sound. And notice how I'm making this, all right? Just a property and a method. That's it. Now, of course, since we have a class, and let's assume that we are creating an application for a store that sells maybe just guitars, basses, banjos, and all those instruments that have strings, right? So what I'm going to do, I'm going to create a new instance of a guitar. And whenever I use guitar, since I have a class of an instrument with all the properties I need, I'm going to use this class on this guitar. So I'm going to create a new instrument, just like this. And now, of course, what I can do, I can access guitar, and guitar will have available all the methods and properties inside of the class, right? So if I do guitar dot and then I do sound, we're gonna get that console log. If I do console log and guitar, we get access to the strings. So I can say guitar, for example. Oops, sorry, the keyword's kind of funny. Guitar, and I'm gonna output the amount of strings. So we should be getting the classic sound and the number 6 if I run this script. You know, pretty simple, you know, pretty basic. We're just creating a class, we create a new instance, and since this one, it's using the instance of this one, we have access to the properties and methods inside. Yeah, pretty simple. Now, what happens if I wanna, let me delete this, if I want to create different types of instruments? This one is a little bit global, you know, an instrument could be a bass, could be a guitar, a banjo, could be whatever. So I'm gonna do class, and I'm gonna create a new class, but this one is gonna be for guitars, all right, just guitar. And then I'm gonna create a new one for, I don't know, bass, right? So these ones, of course, are different. They're not so different because they are classes, but there's no link between them. They are not related at all. So what we can do with classes, we can use the parent class to be inherited from within a child class, and we can use and inherit, and that's, you know, the keyword inheritance. We can inherit the properties and the methods and everything it's inside of the parent class. And we use this, we make this, we actually extend this class with the keyword extends. And I'm pretty sure you've seen this extends notation. So I'm going to do extend, and I'm going to extend instrument. So now whenever I create an instance of a guitar or a bass, we have those methods available, because what we are doing here, we are kind of making this class a child of this class. So all the methods and properties are available within the child class. So, you know, let's pretty much do the same example than before. I'm going to do const, and I'm going to do guitar. And I'm going to be using a new guitar. Let me just go to new, and then guitar. Now, notice that I'm not doing a new instrument. I'm creating an instance of a guitar. And right now, it's empty. But since we are extending the instrument, we have the strings and the sound property available here. So if I do pretty much the same thing than before, I do guitar and I do sound, open and close, and I run the script, we are gonna get, let me do clear first, we're gonna get the method. We have access to the method of the parent, right? And again, this calls inheritance. And I'm gonna do the same thing for the base, since we have it right there. Let me create the instance first. I'm gonna do const, and I'm gonna do base. And I know this is, you know, pretty simple, but I'm gonna need to do it. And I'm gonna go and say base, and I want to get the same property, right? So if I do it, we're gonna get 2 classic sounds, one from the guitar and one from the bass. Even though they are different classes, they are inheriting the same property from the same parent, right? So by doing this, we can get many classes using the same blueprint. And that's why we use a parent class as a blueprint. So whenever we create a new class of something, extending something, a different class, what we can do, we do get access to the properties and methods inside, and we can kind of override them. So in this case, I'm going to say I'm going to grab that sound method we are getting from the parent to child, and I want to say console log, and I want to change it to something else. So I want to say modern sound, whatever, it doesn't matter. And I'm going to do the same thing with the guitar. So let me go here, do sound, and this one, instead of classic sound, I don't know, trashy sound. So now we are outputting that property. So if we run this, we are getting the trashy and the modern sound. So whenever we inherit a class, right, to the child, we do get access to the properties and methods inside of the parent, and we can overwrite them with different values. I know that right now this is very basic and makes no sense, but on the next lecture, we're going to talk about applying TypeScript on the classes and inheritance and properties and methods and all this that we are doing right here. We kind of need to know that how to do this, because we can apply TypeScript on top of here, right? So okay, that's cool. Let's go to the next section and let's see how we can apply TypeScript to classes. All right, so let's see how we can apply TypeScript on classes. So I'm going to delete maybe the base class, because right now it's just, making the code a little bit more confusing. So I'm just going to leave the guitar and maybe the instrument. That's it. Okay, so of course we don't need to learn everything all over again. We know how annotations and inference work, so we can apply them right here, and that doesn't change. It's the same exact notation. We don't need to learn them again. For example, if I want to add annotations into a class, in this case, in the class of instrument, I have a string and this is a number. What I will need to do is just to put the colons and say that this is of annotation number with not a capital M. That's it, and that's, the annotation. If you have a function or a method, same idea. The function or the method needs to return something. In this case, since we are not returning anything, we're just going to go and say void. And this applies for arrays, for the methods, for everything that we've learned so far. This doesn't change, and that's good news. Now the thing is that with classes, we get a lot more things. If we go to the documentation and if I go to classes, they will give us different examples, and I'm going to be using some of these examples. This is what we're going to do right now. But we get some other features like modifiers, and this is what we are going to talk about right now. This is important. So with modifiers, we can use the keyword public, private, and protected. So on other languages, we do get modifiers by default. But with JavaScript, we have no access to modifiers. So if you want to check on the docs, and you find it under classes, you can read the documentation. It's, this one, it's pretty well explained. If not, of course, I'm going to show you right now different examples and what we can do with this modifiers. Okay, so we get three different modifiers. We get the public, we get the private, and we get the protected. So the first one is going to be the public modifier. And this one is pretty simple. We can make some properties and methods. We can make them public with the keyword public. And this means that they can be accessed anywhere, anytime, right? Pretty simple. We just make them public and we can access them anywhere and anytime. And that's okay. Not so hard. Then we get the private. Now the private, it's much more specific. If we make a property or method private, it means that we can only access this methods or properties within the same class. If I want to use them on different classes by extending a class, we cannot use them. It's not allowed because they are private. We can only use them within the same class. And then we get the protected. And the protected, it's kind of like private, but a little bit, less private. So, of course, when we create a class, we make a property, for example, protected, and we can use them inside within child classes. And this is what's protected can do, is it will allow us to use properties within the child class. If we wanted to create an instance of instrument and use that property, we cannot do it. We can only use them within child classes. So remember, again, just to sum everything up, we can use the public modifier anywhere and anytime. We can use the private, so it's always within the same class. And if we use protected, it's the same class or child classes. That's okay. We're going to do the examples right here on the code, so we can learn them by, actually doing them. I'm not going to do this. I'm just going to create a class that extends instrument, and I'm going to do this, create a new instance of guitar, and, that's it. That's the only thing we're going to do. So first, it's the public. Why would we use the public? We can use them, we can make them public and use them anywhere, anytime. So I'm going to go to string, and I'm going to say public. All right. I'm going to go to sound, and I'm going to say public. Okay, so what are we changing on this code? Nothing. We can still override the sound property. We can still use them on different instances. We can create a new instance of instrument and use them. So again, whenever we make public, this is more like an annotation kind of thing. We are saying that this property or this method is just public. That's it. There's nothing else we can do. It's just pretty much like doing nothing. Now there's one very specific scenario where public gets really, really useful, but we're not there yet. We're gonna get in a couple minutes, because I will need to create a much more complex example. But that's okay. For now, notice, just remember that with public is like pretty much doing nothing. We can access this properties and methods anywhere and anytime. Then we get the private. So the private, it's much more specific. For example, the private means that we can only use the method or a method or a property only inside of the same class. So I'm going to go and pretty much do the same thing. I'm going to make them private. I'm going to go right here and make them private. So now string, it's a string, it's private, and sound, it's private as well. And on the other class, on the class guitar, we are extending instrument. So previously we were able to access the property and the method. But right now, we are not going to be able to do this because they are private. So now if I go right here at the bottom and try to access that guitar and use the sound method, we get an error. So it's telling us that, sound, it's private and it's only accessible within the class instrument. So we cannot use them outside. So if I wanted to override them, for example, let me just delete this, and go inside of the guitar class and make a reference to sound and try to override with, something else, we are gonna get, an error. It says again, guitar expects the guitar class cannot use the property sound because it's private. So again, whenever we make private, we can only use it within the same class. How can we use this? How can we do it? Well, pretty simple. We cannot use them outside, but we can use them inside. So in this case, I'm going to create a public method called alert. You could call this whatever you want. It doesn't matter. And this one, the only thing it's going to do void, right? So now since alert, it's public, we can use them on child classes, or we can use them anywhere. But what we're going to do right here, I'm going to make a reference to this and then sound, which is private. And since alert, it's inside of the class instrument, we do get access to methods and properties. So now inside guitar, the alert method will be available because it's public. So if I do guitar, let me do it correctly, guitar, I'm going to do guitar, dot, and alert, we are not going to get an error message. So if I run this, of course, we're going to get the classic sound. So we can access these methods and properties only within the same class. So we can do this trick, that's going to work. So what is the point of using private modifiers? And there's a very specific scenario. Let's say that you're building an application, and of course there are a lot of people working on the same script. And, again, you work with different developers. So the other developer is going to go create a new class of guitar that will extend this blueprint, which is very important. And they're going to say, oh, okay, well, I need that sound method, but I need to change what's inside of here. So since this one is private, they are not allowed to change what's inside of this method, because this one, it's really important and should not be changed. That's why you made it private. So they will instantly know that they should not change that property, that they should do something like this, right? That's, pretty much why we will use private, to prevent other developers from changing. At the end of the day, they can always go to the main class, to the parent class, and change whatever they want to change. But since you made it private, it's like they know that there's kind of a warning with this, that this is kind of a little bit sensitive. So they should not change it unless, it's very important. And, that's the main point of using private. So another thing that you cannot do with modifiers, not just with private or public or protected. Another thing that you can do, you cannot change modifiers. Let's say that this one, of course, is public. Let me just make it public. So we can access sound from within the child class. What you can do, you cannot do actually. You cannot go here and say, oh, okay, so now I want to make this private. This will not work. This is not allowed. It will not let you do it. You cannot change the modifiers within child classes. So then we have the protected. So the protected, the modifier, is gonna in between of the public and private modifier. So when you mark a method or property as protected, it means that you can access from within a same class, from within the same class, or from within a child class. So let me go back to the previous example. Let me just go back. So public sound is going to be public, and we are extending guitar, and we don't have an alert method, so I'm going to delete that. And guitar, let me just go back on this one, and I'm going to use the sound, and I'm just going to try to, override that method. Something, went down my throat. Okay, so since it's public, we can access from within a different class. We can access from within the same class, and if I wanted to, I could create a new instance of instrument here and access class, because it's public. We can really access it. Now, what happens if I make it protected? I'm going to do protected, and we get no errors, because with protected, we can use them within a child class. Notice that we are extending the instrument. If I make it private, we know that we cannot do this. We cannot modify or access sound because it's marked as private. But with protected, we can do it. So let me just go back to protected. We can access and override, and we can do pretty much whatever we want as long as this method it's being used within a child class. So again, you must be thinking, what is the difference between public and protected? Because if I mark this as protected, as public, we can do the same thing. Well, the thing is that with protected, if I wanted to create a new instance of an instrument, let's go right here, instrument, and this one's going to be a new instrument, and I wanted to access or do something with sound, it's not allowed. We cannot do it. If I do sound, we get an error, because sound can only be used within the same class or on child classes. We cannot access them directly because they are protected. And this is the main difference between public and protected, right? We get an error. We cannot use them like this. So another thing we can do, let me just delete this. I'm gonna use the sound method because it's protected, so we can really use it on a subclass, right? That's allowed because it's protected. Now, if I wanted to do something like guitar and then go and do something with sound, we are not going to get an error. We can still use this because it's been protected, but within the parent class, not the child class. So if I mark this as protected, it will not let us use it because, again, we can only use it on a child class. So if we create a new class and we extend that class with the guitar class, then we can use it. But again, whenever you mark something as protected, you can only use it within the same or within the child class. That's it. That's the difference between public, private, and protected. And they are really, useful. And we're going to be using them a lot in this course when we move forward, right? Because right now we need to talk about some other topics. So let's go to the next one and talk about the constructor. Okay, so now we are going to talk about the constructor because so far we did pretty much everything directly on the methods or the class. So what happens if I want to pass an argument when I create an instance of a class and pass some initial values? Don't worry, I'm gonna show you this. I'm gonna delete the class guitar because right now it's getting a little bit confusing. I'm just gonna leave this code. This one, it's gonna be private for now, and this one protected. And then what I want to do, I want to create a new instance of this class. So I will create a new instrument, just like this. And I'm gonna say that this one, it's equal to a new instrument. So when I start this, what I want to do, I want to set an initial value for strings. Right now, this strings, it's a number and it's kind of hard-coded to be 6. So what I want to do, I want to change it. So if I set it as private, remember, I cannot modifier. So I need to change that modifier to delete it. I could make it public. I'm just going to leave nothing for now. But we are still saying that this string, it's a number property and that it's equal to 6, right? Pretty simple. Now, what I want to do, I want to change it to something else. First, I'm going to go and say console log, and I'm going to console log the instrument, and I want to console log that string property. So if I run it on the code, I'm going to get 6, right? Okay, makes sense. So let me do clear again. And what I want to do, I want to, create this instance of a class, and I want to pass an initial value, because maybe when we create this instance, the numbers of strings, it's wrong. It's not 6. Maybe we will get a base, so we're going to have 4 strings instead of 6. So if we had a function, we could easily do something like, I don't know, function A that has some arguments, for example, that we have some args, then we can let strings, for example, we can start at variable but not assign a value, and then we can do string equal to whatever we are passing on arguments. That's what will work on a standard function. But again, we have a class. We cannot do something like this. This is not allowed. And notice that we instantly get an error message. It says expect 0 arguments but got 1. So since we are trying to create a new instance of this class and this class expects no arguments, we're going to need to change a few things. So the first thing is going to be not adding a value to the property string, because we are going to do it from here. So we're going to leave it just like it is. We are still getting an error message. So the way we get with JavaScript, and this is not TypeScript, it's just JavaScript, the way we get to pass arguments whenever we create an instance of a class is by using the constructor. So let me go here and let me add that constructor. And this is something that it comes built in with JavaScript, not with TypeScript. So I'm going to use the constructor. So open and close, and there we go. So the constructor is going to be, this class is going to be expecting some arguments. And the argument we're going to pass is going to be some strings. So then what we can do, we can say, okay, so I want to do this, that's strings, and it's equal to strings right here. And I'm going to change it from here, strings. So now remember that when we have a constructor on a class, and again, this is just JavaScript, the constructor always runs first. When we create an instance, the class is going to start, and the constructor is going to start first. Doesn't matter what we have right here. First, the constructor is going to kick in. After it's done doing things on the constructor, then it's going to go to the rest of the code. And since we are assigning a value to strings right here, it will go and put it right here on this property. So if I do strings, let me change it right here at the bottom, we get no errors. I'm going to run this code, and we're going to get 4. So we are starting the new instance of the class. We are passing the argument, is going to the constructor first, and it says, oh, okay, so whatever I start, I'm going to have a property called strings, and that value is going to be equal to whatever he's passing. In this case, 4. And this is going to work. This is not bad coding. Now the thing is that we are getting a lot of errors. Not a lot of errors. We are getting just one warning, and it's going to say parameter strings implicitly has an any type. Now, if you remember, we discussed this previously. We should always avoid the any keyword. All right. So how can we change this? Well, same thing we did before. We're going to go here, which is the argument, and we're going to say that this one, it's expecting a number. So now in the future, if we wanted to, pass something and we pass the incorrect value, of a string, for example, is going to say, dude, this one should be a number. And now we are using the full power of TypeScript, right? It's giving us an error message. So that's cool, you know. Remember that the constructor always runs first, so it doesn't matter where we put it. If I put strings right here at the top, you know, this is still going to work. If I run the code, this still works. It doesn't matter where we put the constructor. This will always run first. Now remember, and you just noticed, if I remove this, the constructor has no place to put the, you know, the property. So we have no way of using it. So we always need to leave the, we need to create this to declare it and then go to the constructor and assign a value. So there's no other way of doing this. Now, so the problem we get with this one is that we are using strings, strings, again strings, and strings again. So if you have a pretty long class, this is going to get a little bit annoying. Let's say that you have, I don't know, 5 or different properties. You're going to do this 5 times. So it's a lot of coding. It makes no sense. So now the public keyword, you know, the public modifier that was pretty much useless comes pretty handy. So what we can do, let's just notice that I'm going to delete all of this. What we can do, we can use that modifier and we can say that this one is public, and that's it. We get no errors. If I run the code, this still works. So this public behind the scenes is going to convert the code pretty much to this, and it's going to do it for us, so we don't have to write everything all over again. So, you know, pretty handy, the public modifier. So again, public is going to save us a lot of time. So really cool. If you don't super get everything, don't worry, we are not going to use everything that we are doing all the time. Of course, we're going to do some more real-life practice in the future. And again, if you don't get it 100%, don't worry, just keep moving forward. Now, if you check the docs, you're going to get examples of pretty much you know, what we did right here. So you're going to get a few more examples. Now, if you go to the documentation, we get the modifiers and everything else. Now, notice that we get more things. We get the read-only, then we get the accessors. What else? We get the static properties, abstract classes, and so on. So we get a lot more features, or a lot more tools with TypeScript and classes. And on the next couple sections, we're going to be discussing them. I'm going to show you why you're going to use it, or how to use it, and you know what we can do with them. But again, these ones are just more specific code. We're going to use them on specific scenarios. So again, you're not going to use them all the time. But again, this is a course. I need to show you all of these tools. So let's go to the next one, and we're going to do Accessors. Let me see if I can find it right here. Accessors. And this one, it's pretty cool. So let's go to the next one and to Accessors. Okay, so now we're going to talk about Accessors. Remember that you have some documentation right there. So now since we understand what's going on with modifiers, then we can go to Accessors. This is going to be much simpler. I cannot teach you some things. I cannot, teach them to you because we don't know them. So we always need to go in order before we can go to some topics. So for now, let me just delete all this and create a new example. I'm going to create a class, and this class is going to be class of user. Really simple. So we're going to get only one property, and the property is going to be, the property name, and it's going to be a string. And this one, it's going to be equal to Ron at the beginning. Now, notice I'm using the underscore. It's a little bit weird, but don't worry. I'm going to tell you why in a minute. It's going to make sense. So I'm going to create a new instance of this. I'm going to create a new user. So new user, all right? And then I want to output that console log. Nothing weird so far. So user underscore and name. And notice I'm not getting any warnings, any errors, nothing. I'm going to do clear. I'm going to run the code. And we know, of course, that works. Pretty simple. Now, what happens if I make this private? I'm going to go and make it private. Told you, we will need to know modifiers. So, of course, we cannot do it because we can only use this property within the same class. We cannot use it outside of the class. This is one, it's not allowed when we use private. And now it's when the word accessors makes a little bit more sense. With accessors, we can access properties that are, in this case, private. We can access pretty much whatever we want, but in this case, it's going to be really useful because what we want to do is we want to access from outside the class on a new instance, but we want to access a private property and we want to get the value from outside or to set the value. And that's what we are going to do with accessors. You use get to get a value or to set a new value for this one. So first we're going to do the get. Let's try to get it from outside. So whenever we use accessors, we use get or we use set. So in this case, I'm going to get, so I'm going to write the get. Now when we get with accessors, we need to use the same name of the property we are trying to access. In this case, it's underscore name, and that's okay, but we should not use it like this, and that's why I'm using the underscore. The actual property starts with underscore, but when we use an accessor, we use it without underscore. Notice that I'm getting a fat error. So if I do it like this is going to work. And we use it just like a method. Even though it's not a method, we use it just like this. Now it says a get accessor must return a value. Whenever we use a get accessor, we always need to return something. Now in this case, the accessor is going to return the value, this value. So we're going to make a reference to this dot underscore the name, and that's it. So, pretty simple. So now notice that we are getting an error because we are trying to access a property that is private. So to access this, whatever value we have right here, we get this accessor. So what I can do user.name, and that it's going to work. So what is the advantage of using an accessor? Well, the thing is that for now, you cannot access this property because it's private. So when you use an accessor, you allow whatever developer, the developer, to access whatever value you have on this property from outside of the class. Now, the benefit from this is that you cannot modifier. You're only letting the developer access the property from outside, but you cannot modify it because the name it's different and this one is private, right? That's the advantage of using a get accessor. So getting the value, pretty simple, right? We are just getting it. Then of course with accessors, we get the set, and this one is going to be a little bit different. And we can kind of do it the same way. It's pretty much the same idea, but since it has a different idea, we kind of need to change some things. So first we start with the set, and then we use the name of what we want to set, what we want to change. And this one doesn't change. We are still doing name. Now, even though we are doing this correctly, I'm getting an error message. It says that an accessor set must have exactly one parameter. So if we're going to set a new value, of course, we're going to set it from outside, and we're going to set it with a new value, and we need to provide that value. So this one works just like a function or a method. We need to pass an argument. What is the new value is going to be? Now, if I leave it just like it is, that's good. But what you can do, you can add an annotation to this one. Now, what is the point of doing this? Well, think of an accessor like an if-else statement with get and set. In most of the case on set, it's just like an if-else statement. If we are going to decide right here in this code if we want to change the value or not. We can evaluate and let the developer modify the private value of name or not. So I'm going to go with a simple example. I'm just going to create an if-else statement. And don't worry, this is going to be very simple. You're going to get it right away. So first, I'm going to check that the value is equal to equal to something I want. In this case, I'm going to say Steve. Now it's run. I'm going to change it. I'm going to check if the value is Steve. So if the value is Steve, it's indeed Steve, I'm going to go to name and change it for Steve. Right. So what happens if the value is not Steve? Well, it means that I don't want to change it. So if the value is not Steve, I want to change it for Ron. And now notice that right now it's still Ron. So I'm changing it pretty much for the same value. You cannot do anything. I'm just, adding an example that it's more visual. So what we're going to do right now is that we have the ability to set a new value, to the private property. And we're going to change it only for Steve if the value is Steve. Right. So now if I want to change it from outside, I'm going to go and say, okay, so I want to enter user. I want to use name and I want to do equal, and I'm going to change it for something else. So I'm going to change it for Francis. So if I run this, and remember we are doing console log username, we are still getting wrong because I'm trying to change it for Francis. And our rule says that we only want to change it if we get Steve. So if I, do the same thing, I'm going to repeat, trying to change that. I'm going to change it for Steve. And since our rule will allow us to change the private property, that is going to work. It's going to pass. So if I do console log name, let me just redo this. After the Francis, we are going to get Ron, but after Steve, we're going to change it to Steve. So if I run this, first we get Ron because this rule would not apply. But then, since we are passing Steve, that is correct. And we are allowed to set a new value for the private property that, shouldn't be accessible. So again, with accessors is kind of an easy way to get values or to set values. But whenever we set a new value, we have a much more controlled way of, changing a private property. It's not something that we are letting the developer do whatever they want right here. We only set a new value if the rules are, met. The conditions are met. All right, pretty simple. Accessors it's kind of a fancy keyword, but this is, pretty simple. So then we get all the things with the TypeScript. We get the static and the read-only. So let's go to the next one and discuss the static and read-only. Okay, so now we're going to talk about the static and the read-only. So I'm going to delete all of this. I'm going to start with a new example. So I'm going to create a class of airplane. Doesn't matter the name, just airplane. And on this one, we will have a property called the model, which is the model of the airplane. I don't know anything about airplanes. I don't know if that's a real name, a real model. So then, of course, to use it, we need to create a new instance. So I'm going to say new airplane. And then and only then we can access plane. And I'm going to do a console log first, console.log. And I can access plane and I can access the model if I wanted to output it right here. So let me do TS node and we get the model. That's good. Nothing new so far. So what happens if this property, it's a private property? If we make it private, and now since we know modifiers, we know that we cannot access this property outside of the class. We can only access inside of the class. So what are your options? Now that we know accessors, we know that we can use an accessor. So I can do underscore right here, and I can use the get model. And remember that the accessor always needs to return something. So I'm going to be returning, and I'm going to return this dot underscore model, and then, problem fixed. We can access the model from outside of the class, even though that property is private, right? We know this. We just discussed this a minute ago. So what happens if we want to use read-only? So the read-only, it's kind of serves pretty much the same purpose, not the same thing, but pretty much the same idea. Okay, I'm going to delete all of this, and I'm going to make this private, and all right, I'm going to make the private read only. So now the property, this model property, can be accessed from outside, but it's marked with read only. So we can only, and the only thing we can do is to, have access to whatever value this model property has. In this case, if I run the code, we get it. Now, what happens if I try to modify it? If I go right here at the bottom and I try to, change it for something else, I'm going to do plain, I'm going to do model equals to, whatever, something else, we get an error because, again, self-explanatory, this one is read only. We cannot change it. We cannot mess with it. So the only thing we can do with read-only properties is to access from outside of the class, or maybe try to access that property from within the same class. So if I wanted to change it within the same class, again, same idea, it's not allowed. So I'm going to do change. This is going to be a method. Of course, we're going to do void. And if I want to say that this dot model equals to, I don't know, something else, we get an error. Again, it's read-only. We cannot change it. So why would we use a property that it's read-only? Well, maybe you have a class that later on the class right here, you're going to do some very specific code and you need some configuration properties, maybe with some values, maybe with the date or something like that. And you don't want to mess with them. You don't want to change them by error or mistake or whatever. So we're going to use them. You're going to mark them as read-only. So you can only get values, but not change them to different things. That's why you would use a read-only property. So then we have static. So let me just go roll back the example just a little bit. We do have access to static in newer versions of JavaScript. At the end of the day, when we compile all this, it's going to be compiled to standard JavaScript, to vanilla JavaScript. And for that one, we don't have static. So for now, I'm going to create a class called airplane. Again, we have the same example, and we create a new instance of new airplane, and you get it. So I'm gonna delete this. I'm gonna delete the instance, and I'm gonna try to access this property directly. So if I try to do it, of course, we get an error message. So in JavaScript, not TypeScript, we cannot really access this property directly, just making a mention to the class. It's just bad JavaScript code. We cannot really do it. So we always need to go, and let me just go back to the previous example. We always need to go to create a new instance of this class, and then and only then we can access the model, right? There's no other way to do it. That's why we need to do this. So here, the static comes really handy because maybe what you want to do, you want to access a property inside of a class, and you don't want to create a new instance. Why adding this code when you just want to get this value? So what you can do, you can make use of statics. So if I go and mark this property as static, what I can do, and I'm going to delete this, I can access the class directly and say that I want to get that model value. And if we run this, we're going to get that value. It's going to let us access and get the value. So pretty simple. It's just something just to simplify the code, because maybe you just need this this property and this value, and why creating a new instance and going through all of that coding when you just need one thing. So now static comes pretty handy. So of course you can do this with methods. If I want to create a static method of, I don't know, alert that is going to do void of something, and then on this one we are going to do maybe a console log of alert or something like that. Same idea. Since this one is static, we just can access that directly. In this case, I can do airplane just like this and go to alert and trigger that. So alert. So notice we get no errors, and if I run it, we get the model and we get the alert. All right, pretty cool stuff. Simple thing, the read-only and the static, but they could they could transform into something very, very handy to have. It's a very useful tool. Okay, so let's go to the next one, and we're going to talk about abstract classes. Okay, so now we're going to talk about abstract classes. And if you go to the documentation, you get some examples. If you just look at this without reading, without any logic, it's a little bit confusing. And this is something, again, it's just another fancy word to do something very simple. I'm going to create a new example and just explain you what this is all about. It's pretty simple and useful. I'm going to create a new class called movies. Just like that, just movies. And when this class starts, we get a name, just a property with a string, and the property is going to be default. Again, something simple. What else? I'm going to add maybe a director, and this is going to be a method. Since we're not going to do anything, I'm going to just put void, and I'm going to do a console log of something dumb, maybe the name of a director, Tarantino, and that's it. That's our class. So then if I want to use it, I'm going to create an instance of movies, not with a capital M, just movies. That's the autocomplete kicking in. And of course, we create a new movie or movies. And then of course, if we do a console log, we can of course access whatever we want. If we want to access the name, we can do name. And if we want to access the director, we access the director. So far, nothing new. We know that this works. So when we talk about abstract, we can make a class abstract, and this means that if we make it abstract, this class is going to be we're going to make it unusable for a direct instance. We cannot use them on an instance of a class. So we cannot do that. When we make it abstract, we can only use them by extending this class with a subclass, on a child class. Let me just show you. If I go right here at the top and say abstract, just like this, and save it, notice that we get an error. It says cannot create an instance of an abstract class. So if we make it abstract, we cannot create an instance of this class. It's just not allowed. So what we get with this one is that we can create an abstract class to use it like a blueprint, like a main core class that will get extended on child classes. If I wanted to make this work, I will have to create a new class called, pick, and I need to extend the class of movies because it's an abstract class. And if that is the case, I'm gonna need to do a new pick, and that will work. If we run this code, we're gonna get default. So this is the only way we can access the name or director if we are using an abstract class. We can only do it through a child class. All right. So you might be thinking, what is the point of doing this, using this? Well, you can use an abstract class as a main blueprint. Let's say that you're creating an application, and then other developers will use your abstract class. So by doing this, you're preventing from them to use it on an instance. That's the first thing. They will need to go through their own class and extend the blueprint class you just made. And that is the first purpose of an abstract class, and it's really, really useful to use it as a blueprint. Now, the other thing that you can do that it's really, really useful is that you can use abstract properties or abstract methods. You can make them abstract. So if I go right here to this property, I can say abstract, just like this, and I'm going to make this property, this method, abstract. So the thing is that whenever you make a method or a property abstract, you must not add an implementation. We are declaring and adding the implementation, and that's why we get an error message. Whenever you get a property or method abstract, you should not add an implementation. So if I delete this, everything works. All right. So now we have no implementation. We are just creating this. So the other feature we get with abstract classes is that whenever we make a property or method abstract, we are forcing the developer that's going to be extending the class to add that property on their code. And now it's getting really useful. I'm extending movies inside pick, and notice I'm getting an error message. If I hover this, it says pick does not implement inherited abstract member director. So in this case, it's forcing me to add a director method and add an implementation. So I need to go through director and add whatever code. So in this case, I'm going to do console log, and I'm going to put my Tarantino. So with this, again, we are forcing the developer that it's going to be extending the main blueprint class to add some code about that director property. Of course, if we remove the abstract, we don't need to add this. But again, we are forcing the developer to do it. Because maybe in the future, some other developer will extend this class, and they will forget to add something like this, and they will instantly get an error message saying, dude, you should use that director property. That's why we've added to the blueprint. So you need to do it. Same idea on properties. If I do abstract, just like this, it's forcing me to add a name property right here. If I do name, I need to go through this and add in a name. That's the first thing. And the other error, again, we shouldn't add no implementation to this. So if I do name string, that's going to pass. If not, we're going to get an error. Again, it's just a nice way to force developers that are extending the blueprint class to use the code that they should be using. Now, another thing is that you can only use abstract properties or methods if the class is abstract. That's the only thing. If I remove the abstract on the class, we get an error. We cannot do it just like this. So again, it's a nice way to have a blueprint class that we will extend, and we have some ground rules of how we need to use that class. And if you're asking yourself, is this really useful? Are we going to use them? Are we going to use abstract classes the whole time? Well, yeah, it's one of the features that are, it's if you're working with classes, this is really, really useful. It's one of the features that you will use, not the whole time, but pretty much the whole time. You will only get at least one blueprint class, just like this one. Alright, so we've been talking about different pieces of TypeScript and how to use part of this to do things, inside of the JavaScript and TypeScript world. But what happens if you need to create an application and you want to use TypeScript? How to make it work with the files, with your project, and then the browser. So, and I'm talking about a normal application, HTML, JavaScript, TypeScript, and maybe some CSS. I'm not talking about Angular or React or Vue. We're going to talk about them later. We're going to do something with React later. And we are still on the basics. So first, we need to create a project and an environment. So I'm already inside the project _02. This is the name of the directory where I'm at. And I'm going to need to create a project. So I'm going to go to New Terminal, and I'm going to do the good old npm init. So I'm going to press enter, and of course it will ask you the package name, project name, and everything else. Again, I'm just going to keep pressing enter until we get, and I need to update the npm, but that's okay. I'm going to keep pressing enter until we get the package.json. All right, again, we kind of already did this. Now we're going to create a project, and we need to run our project on the browser. So for this one, we need a server. And right here, you get many choices. You can run it on an Express server, or you can create a Webpack. You can use Webpack to create a development server. And you get, you have a lot of libraries just like Webpack, where you get a lot of features, but they require some setup, some amount of setup to make it work with TypeScript and everything else. Later, I'm going to show you how to do it with Webpack. But for now, I just want to show you how to create a simple application with just JavaScript, an HTML, and a CSS, and make it work on the browser. So instead of using something that it's really big, just like Webpack and Express, we're going to use something real simple. We're going to use something that's called Light Server. And this is a library from this developer. We can install something and just, run a very small server. So I'm going to go, I'm going to go right here to the terminal and do npm install, and I'm going to call it Light Server. So again, you should do the same thing. All right, so everything got installed. We get our Light Server right here, and we get the node modules. So that's, that's correct. So that's good. What else do we need? We need an HTML, so we can, put it on the browser. And then we need a TypeScript file. So first I'm going to go here, and I'm going to create an index.html. And this is what the Light Server is going to look for, index.html. And, by default, you get some HTML markup. I'm going to create a head. What else? I'm going to create a body. Something simple. You're not going to do anything right here. You're just going to try to run it. So I'm going to, just put working right there. All right, so what else do we need? We need a TypeScript file. We are not going to use it right now, but we're going to use it in a couple minutes. So I'm going to create on the root directory an app.ts file. All right, but that's okay. We're going to use it in a minute. So now what I want to do, I want to run that server and show the index.html on the screen. So we need to go to the package.json and let the application know that whenever we want to run it, so I'm going to go to start, we want to run that Light Server. Pretty simple. Again, this is not so much related to TypeScript. Okay, so if I go right here and we do npm start, the light server is going to kick in, and it will open a local, and notice it's very fast. It will open a local host on 3000, and we get the working that we got on the HTML. Not magic. This is pretty simple, pretty standard. So what is the deal right now? The thing is that we want to make our application work with some, JavaScript code. The thing is that we are using a TypeScript file. So we cannot put a TypeScript file on the browser because the browser cannot understand TypeScript. So in this case, I'm just going to go right here and put some dumb content, maybe something like working, doesn't matter. Okay. So then what I want to do, I want to compile this TypeScript file into a JavaScript file. That's what we need to do. We need to compile whatever code we have in TypeScript to JavaScript and then pass it to the HTML. Okay, so in this case, since on this terminal we are running the server, I need to open a new terminal. And on this one, the way we get to, of course, compile, we know that we can do TSC and everything else. Now, I'm going to show you something else, and this one, it's new. So whenever we do TSC, we, just like we get with NPM, we can create a configuration file. So if we do TSC ---- init, I'm going to press enter, it's going to say successfully created a tsconfig.json file. And this one works just like the package.json. On this one, we can add configuration options, and notice all the options we get, all the things we can do with TypeScript when we want to compile or do things or add some rules to TypeScript. So we get a lot of options, and we're going to go through some of these options, the most important options, in a couple minutes. But notice that, remember that you can run ---- and you will get a configuration file. All right. So then what I want to do, I want to compile our TypeScript file into a JavaScript file so we can pass it to the HTML. So since we have our init, and it's going to come handy in a couple minutes, we can do TSC, and that's what is going to do is going to go and read all the files on our root directory, and if it's finding one that it's ending with the extension TS, it's going to read it and it's going to convert it to app.js, and it's going to save it on the same directory, on the root directory, right? On the same directory where we have the TS file. Yeah, that's cool. Now we have a compile, even though we are just doing a console log, we have a compiled version of our TS file. So now the only thing we need to do, since we have our app.js, JavaScript file, we can go to the header and we can do script and, just pass it. So source is going to be, of course, let me just open and close, and we can do app.js. And if I save it and rerun the application, we should be getting that console log, right? All right, so we get it. It's working. All right. So this is the most, most simple way of running a project with a TypeScript file. You just add the TypeScript code, you compile it, and then you feed it to the HTML. Pretty standard. Of course, there's a lot of things we can do, and there are a lot of things we can do with the TypeScript, with the config file. And that's what we're going to do on the next section. We're going to go through some of the options and some other ways of, adding to compile the TypeScript file. So let's go to the next one and let's check the compilation options. Okay, so on this section we're gonna use some options. We're gonna check them out, and of course we're not gonna check everything because this is gonna be very long. But I'm gonna show you how they work in a nutshell. And once you get, the most important ones, you're going to know how the other ones work. Either way, of course, you get some documentation. Actually, you get pretty much all the documentation. If you go right here and you go to the last option, project configuration, you're going to get the tsconfig.json, and they will give you a description of what you can do with most of the properties right here. But that's okay. I'm going to show you right now. We're going to do a lot of stuff. So, okay, so some of the options that actually are not here, and here you get the compiler options. Some of the options that you don't get right here, in a commented way, are the files option, and then the include and the exclude. Let me just give you an example, and you're going to get it, don't worry. I'm going to go at the end of all of this. Notice that these ones are inside compiler options. I'm going to go just, after the compiler options. I'm going to do comma, and I'm going to add something that calls files. So of course, right now when we run the TS to compile, TypeScript, it's going pretty much through the whole project, and whatever it's finding right here is just compiling it to a JavaScript code, JavaScript file. So on the files, we can give some instructions of, which files we really want to compile. In this case, if I say app.ts, it's going to only, run this app.ts. That's, why we have this files option. If I go to files and go to the app.js and delete it, and we run the tsc again, it's going to go through that one and it will compile it to JavaScript file. So then we have some other options. For example, I'm going to just remove these files. We have the include and the exclude, because most of the times you're not going to get your TypeScript files on the root directory. Most of the times you just put them inside of a directory like JS or JavaScript or source or something like that. And I'm going to do just that. I'm going to create a new directory. I'm going to call it source, and inside source I'm going to create a new one called JS, and I'm going to delete the JavaScript file so we can compile it again. And on the source in JavaScript, I'm going to put my app.ts inside there. All right. Whenever you change files, it's going to ask you to change the imports. I don't want to do it right now. I'm going to do it manually in a couple minutes. So I'm going to go right here, and I'm going to instruct TypeScript where can the application file, TypeScript can find this app.ts. I'm going to instruct to look inside of this folder. So for this one, you get the include. So the include, of course, kind of a self-explanatory, is going to say include, whenever you compile, include this directory only. So with this one, you can do source, because we want to go to source. And then I'm going to say, and this is of course on documentation, you can say at and look any directory and any TypeScript file. And this is going to go, it's going to look on source, going to look on JS, and then it's going to look, whenever it's finding a TS, it's going to compile it to, whatever we want to compile. If I run TSC, it's going to look on that directory, and it will convert the JavaScript file just on the same directory. If it's finding this TS right here, it's going to create a JavaScript file and put it on the same level, right? On the application, not on the root level. Then we get the other one, which is the opposite of include, which is going to be exclude. And on the examples, you get pretty much the most common examples, which is going to be exclude the node modules, right? Pretty simple. Okay, so let me show you one more thing, and then we're going to go to the next section, and we're going to, of course, check some other options. Now, right now, if I go to console log working, and we are, providing this app.js, creating the app.js, of course, we need to go here and say, source /JS and then app. If we do something like that, of course, everything is going to work. We're going to get our working right here. Now, if I make a change, something like working again or something like that, and if I save it, of course, we are not going to get it. And it's because we need to compile again. We're going to need to go to TSC, compile it. It's going to replace the old with the new one, and then it's going to work. Now, of course, this is a pain in the knees. I don't want to say the other word. So, how can we, make it better? So, to clear, with the TypeScript, we get a watcher, and it's a built-in watcher. So if we do TSC --, and then watch, I'm sorry, it's not --, but that's working. Never tried it, but that's okay. It's working. I was going to do -watch, but --, it still works. So of course, this will add a watcher. If I change this script again and save it, it's going to recompile, and we will see the changes reflected on the application. So really cool. So now we know how to run, how to compile, and how to pass some options, and how to run a watcher. So very cool. So of course, we get a lot of options. So let's go to the next one and discuss some other options we get available with this. Okay, so let me show you some more compilation options. I'm going to delete this, just make it right again. And I'm going to go right here at the bottom. I'm going to write a variable called user. And of course, I'm going to make it a string. And this is going to be the name of the user, right? Everything's cool. TypeScript, it's not complaining at all. But if I go right here at the bottom, I'm going to say user, and I'm going to assign a number. So of course, you're going to get an error, and notice I'm using the --watch, the watcher of TS compiler. So it is compiling, but it's gonna giving me an error because I'm assigning a number to a string. We know that, that is incorrect. Now, the thing is that, of course, this is giving us an error, but if we go to the JS, this is, it is happening. It is actually compiling. So even though TypeScript, it's complaining about that error, it will just go and compile it anyways. And, and this is good because maybe you don't care about the TS errors, because this is not bad JavaScript. You're just changing the nature of the string. But again, in the TypeScript world, this is an error. Now, if you don't want this behavior, you don't want for the compiler to make the compilation, even though you get a TypeScript error, you can actually change it on the config options. If you go all the way right here, you're going to go right here at the top, you're going to go to the basic options, and you're going to have one that says no emit. Now, if you put no emit, if you just uncomment this one, the compilation will not happen. It will not do anything. Now, there is a different option that it's not here. You don't have everything right here. And if you go right here to the compilation options, to the documentation, you get a lot more options. And the one I'm looking for, it's one that says no emit on error. This one right here at the bottom. So if we use this one, it will just not, will not create a compilation if we get an error at all. So if you want to enable this, I'm going to go right here at the bottom, and I'm just going to manually add this one. So no emit on error. So everything on camel case. And I need to set this one to true and, make a comma. So if I go right now and I delete this, let me just delete the JavaScript file. And I'm going to go right here and I'm going to make a change. Remember, we are running the watcher, and I save it. It's going to, not compile anything. Nothing happens. If I save it again, nothing happens. If I fix the error message, I fix it and change it for, something that it's kind of, I don't know, good for something like Steve or something like that. I'm going to save it and the compilation will happen. And again, this is something very simple, but maybe you don't want to run compilations if you get errors. So of course, you can change it right here. All right, so let me show you a couple more things we can do. Of course, I'm not going to go through all the options. I'm just going to go through the most important ones so you can get the idea of how they all work. And let me show you this one. I'm going to show you the out there. So if you notice, when we run the compiler, everything is kind of getting compiled and stored under the same directory where the TypeScript file is. So with this option, we can let TypeScript, the compiler, know that we want to store all the JavaScript, all the compiled files into one single directory. In this case, I'm going to go to JavaScript and I'm going to say just, I don't know, a little bit redundant, but that's okay. We are just playing. I'm going to say I want to store it on source. I'm going to go to JS and I'm going to go to JS and then /. So as soon as I save this, the compiler is going to run and it will, store all the compiled files into JavaScript, into the JavaScript directory. So if you have 100 TypeScript files, all the compiled files will go under this directory. And this is what you're going to do in real life when you compile files this way. And then you get other options like the root directory, for example. We get to the side, and this one works pretty much like this one. We get to decide where the root files are. In this case, we could say and specify right here that they are under source and JavaScript. So it's going to look for that folder only, right? Pretty cool. So let me show you one more thing. So I'm going to go, because our main file, if I delete this one, let me delete this one. Now we are compiling under the source JavaScript and JavaScript. So I kind of need to, go one directory up. So if I, of course, render this and I go to sources, we can see that under sources, we get all the files that are flowing in our application. And that's good. All right. So if I go to app.js, of course, it's going to show us the compiled version, which is this one, the JavaScript file. And that's okay. The thing is that in real life, you're going to get a lot of code right here, ES6 code or whatever, and everything is going to be compiled under on this JavaScript file, and it's going to be everything under, with ES5. It's going to get kind of a little bit confusing to read. So if you need to debug your application with breakpoints, it's going to be a little bit challenging. So we get the option to use source maps. And this is quite cool. Let me just enable this. I'm going to enable and I'm going to save it. Now this one is going to generate an app.js.map. You know, it's just, pretty much the same name, but with map. And this one, what it's going to do, if I reload this application, notice that we get something else. We get the app.js and we get this one. So this one, it's the source map. And notice that on this one, we get pretty much the same code we get on the TypeScript file. So it's kind of the uncompiled version of the code. So if we wanted to run breakpoints, that's going to work. It's stopping right there. And we can debug not only the compiled version of the code, but the uncompiled version of the code. It's a pretty cool feature. You get much more options with the source map. You can, of course, you're gonna get this, but this is pretty much why we would use source maps. So let me show you a couple more things. Right now, of course, we are doing all of these options, and notice that they are inside the basic options, and all of these are the options we get. Just to decide how it's going to compile, where it's going to put the files, and the most basic configuration to do the compilation. Now at the bottom, we get other options, and these ones are different. That's why they are kind of in a different space. We have a space right here, and these ones, for example, are for type checking. Right now we get strict, and this means that every time we get an error or TypeScript error, TypeScript it's going to go and just let us know. So, for example, we get more options to, have to work a little bit better. For example, if I go to no implicit any, and let me show you this with an example. I'm going to go right here and I'm going to create a let called car, and I'm going to just do this. Now we know that if we never initialize the value, TypeScript has no idea what to do with this variable because it has no value. It does not know what it is. So by default, it's going to go and add an annotation type any. Inference is going to kick in, and we have an any variable. All right. Now, maybe you don't want this, and you want to write a warning if you get an any, and you can actually set it from here. If I do no implicit any, I'm gonna select true. I'm gonna go right here, and of course, right now we get nothing because this one is the default. So if we could change it to false, I'm going to save it, and notice that right now we are getting a warning because, again, we are just saying that if we get an any, you should let us know. And by default, it's going to go and let you know if we have an any. I believe that for this option, it's really important because we always want to avoid any's. Everything is going to compile anyways because this isn't a warning. It's not an error. But it's a good idea to know, when we have in our script something with an any, annotation. Okay, so let me show you this with a function because if not, it's going to be a little bit hard to explain. I'm going to explain you some of the other options we get right here. I'm going to go right here and I'm going to create a variable function called glove. I don't know, whatever name, doesn't matter. And that's, the fire squad. I hope it's not my house. Hopefully you can listen, you can hear the sirens. So okay, I'm gonna just boolean. I'm gonna make a boolean. I'm gonna go to functions glove. I'm passing an argument called spin, and then I'm going to go right here and I'm going to say, okay, so I have a variable called shout, and the shout is going to be a string, usual stuff. I'm going to make this a string. I'm going to not initialize the variable, and then we're going to run some code, whatever, and then at the very end, we always need to return something. In this case, I'm going to be returning the shout. Now, of course, if we are not using TypeScript, and if we return this, since we are not initializing the variable, by default, it's gonna return null, right? This function will return null. Since it's gonna not returning anything, in this case, just null, we get an error from TypeScript. So if we are using that, strict no emit on error, this will not compile. Now the thing is that, in real life, maybe your function will return null, or it's gonna return something else. But maybe that's okay for you. You want to return something or null, and that's, okay. So in this case, I'm going to go right here and I'm going to say, okay, if spin is true, I'm going to go and, initialize that variable. I'm going to say it's spinning. Now, even though I'm adding a value, TypeScript knows that we are doing it on an if. And maybe if this condition is not met, nothing of this is going to happen, and we are still returning null. So again, it's just still giving us an error message. Now, if this is the case that you don't care about all of this, about returning null, you can go right here to the configuration, and you get the strict nulls check. By default, it's true, so it's gonna do it just like it's doing right now. But if we change it to false, TypeScript will not complain about that, that rule. And again, another way we get to make our code and our life a little bit easier. All right, so let me show you one more thing. I'm gonna change the code just a little bit. I'm gonna comment this out, and I'm still using the spin, but what I'm gonna do, I'm gonna initialize the variable right here, and I'm gonna go right here and say I want to return that shout. And notice that we are not getting an error message. Now, what's the problem with this? And this is not about coding, I don't know, it depends on what you're doing. This function, it's doing something, and of course, if you go to the if statement, if spin is true, then you're gonna return something. But the thing is that if this condition it's just not met, you're not gonna return anything, right? And that could be a problem. If I go right here, notice that the inference is kicking in, and it's saying that, okay, so this function is going to return a string. And that is true, because we are indeed returning a string. But the problem is that if this fails, you're returning null, and this is just not true, because you're returning null. It's just bad coding again. So you get an option that says no implicit, right here, no implicit returns. And actually, it's not here. Let me see if I can find it. Okay, right here. You get the additional checks. No implicit returns. So on this one, let me just enable. Right now it's true. If I save it, you notice that right now we get an error. So it's not even compiling. So with this one, we are kind of forcing ourselves to always return something and not leave it implicit, right? Makes sense. So in this case, just to fix this, to do pretty much the same thing, I will have to, create a start variable, and then of course return something. Doesn't matter if we are falling to this, because we are ending the script right here. But we will need to go to the end and say, okay, so if the case is that we are falling to this scenario, we will need to go to shout, assign a value, or maybe assign whatever value that is a string, because this one will return a string, and then the error goes away. So again, you get a lot of options, a lot of ways to control your application a little bit more. Okay, so let me show you one more final thing. I'm gonna go to this function, and I'm gonna add just an argument. I'm gonna say planets, since we are working with the globe, and I'm gonna add string. All right, that's cool. Of course, I'm gonna add this variable, and notice that we are kind of not using it. We are not using it at all, not at all. So TypeScript, it's not complaining. It doesn't care. So with this one, we get an additional check, and we can specify for TypeScript to complain if we are not using, are using or not using parameters that are there. So if I set this to true and I go back to my application, we get an error because you're not using the the argument. Pretty self-explanatory. So you get a lot of options to really control. And again, we are not going to go through all of this, but you're going to get the idea of how they work. Now, the main point of this section was to let you know that you do get some options for the compilation to control what TypeScript is doing. You get a file to do that, and it's very, very useful. So when you create an application, you should always go to your tsconfig and kind of tailor the application to what you want to do, what you would like for TypeScript to do. Now, some of these options we have right here, we're going to use them much later on the course because they are kind of far more specific options. We need to have a kind of a much more complex project in order to give you a valid example. For now, we're going to go to a different topic, but this one was good, knowing that we get a lot of options to tailor the application. So we're going to go to something kind of a special, and it's going to be a little bit weird. And you're going to complain, and you're going to say, oh my God, this is just not good. But don't worry, you need to just keep going, and I'm going to show you better ways of using what I'm going to show you in the next section. So we're going to start with namespaces and modules.